Okay, cool. Let's have a go at A4. A4 is a interestingly worded question, which doesn't make things easy. It's taken me a few stabs to get this one, so if you're struggling with this one, please don't worry. It is a particularly nasty one, but hopefully we should be able to do the maths, and we'll go through it now. Okay, cool. So we've got A4, and you've got two normal coordinate systems, big X and big Y. You've got their normal modes, so you've got their time period of oscillation, and you've got an initial displacement for little y2 and little y1, and they ask you after 2.2 seconds, where will the masses be? So, let's begin. Okay, we know that big X equals y1 plus y2, and over the last few questions we've proved that these two positions are base simple harmonic motion, and so we can just give them a standard form solution, i.e. a cos wave, so we know their displacements obey a cos wave. And because X is just a linear superposition of both of them, we also know X will fit into a cos wave as well. We can assume a standard form, a standard solution for the normal mode. Okay, cool. So we have xt, and we can say that equals some amplitude. We'll just call it x naught, and we'll go cos omega x t. This is one nice easy solution there. Okay, cool. And we do exactly the same thing for big Y. This time, of course, it's y1 minus y2, but that doesn't matter. That comes in a second. But again, we can assume a normal form. Okay, cool. Hope that should all be okay so far. Now we can input some numbers. So for each of these normal modes, we've got an oscillation of frequency, which is omega. So we know that omega equals 2 pi over the time period. We're given the time period for x as 1, so rather pleasingly that's just 2 pi. And we'll do the same over here for y, where ty isn't 1 this time, it's actually 0.5 in the question, so that goes to 4 pi. So again, let's just input those numbers. We get x naught cos, and we put in 2 pi t there, and here we get yt equals y naught cos, but of course this time it's 4 pi t. Okay, hope that should all be clear so far. What we can do quite pleasingly now is say that x naught and y naught are both 1. And the reason for this, you can go into a more detailed mathematical approach, but all I'll say for it now is that the first mass, y2, is displaced by 1 centimetre. Okay, it's displaced by 1. And so hopefully, intuitively, it should be clear that the amplitude of both the normal modes should just be 1. They can't be any greater than that initial displacement. If you're not quite happy with that, we can talk about that in a bit. But I'll just, hopefully that should be intuitive. If not, drop us an email, drop us a message, and we'll sort it out. But yeah, the amplitude is just 1, as it says in the question. So quite pleasingly, we can just get rid of x naught and y naught. Okay, wonderful stuff. Right, now what we can do is differentiate them, because this will come in handy in a sec. Again, cos goes to minus sine, so we know there's a minus sign in here, and I've left the gap, as you jolly well know, because we need to differentiate whatever's inside the trigonometric function. Exactly the same process goes for y, except of course we have a 4 instead of a 2 this time. Okay, cool. Right, smashing stuff. In the question, it gives us how big X relates to little y and how big Y relates to little x. In one of our earlier videos, we showed that we can transfer these round and get a solution for little y's as opposed to the big x's and the big y's. So we know that y1 just equals big X plus big Y over 2. We know that y1 differentiated is just the differential of both of these added together over 2. y2, we have a negative sign in between the x and y this time, and the derivative of y2 with respect to time is again just big X minus big Y. Of course, both of those have been derived with respect to time. Okay, cool. So now we have a few sets of equations, and all we need to do is put them together and add in our value for t, which is 2.2. So let's start with y1. So y1 equals big X, which we have up here. So that's just cos 2 pi t plus big Y, which is cos 4 pi t, and that's all over 2. Put a little equal sign there. We'll finish that off in a second. And then y1 dot, again, is just popping in these figures we just worked out. We have minus 2 pi sine 2 pi t minus 4 pi sine 4 pi t, and that's all over 2. I'll take out that equals because that's a bit ambiguous, isn't it? We'll leave it for that in a second. Y2 is pretty much the same as Y1, except there's a minus sign there. So we'll just put that in there. Remember, of course, we're using the values we worked out earlier up here. So this is big X, this is big Y. And the derivative of big X and big Y, again, we just worked out from the original big X and big Y equations. And we'll just chuck those in here again. So y2 dot is big X dot, which is minus 2 pi sine 2 pi t, minus big Y dot, so that's actually plus 4 pi sine 4 pi t over 2. I will leave the last bit up to you, because you've got to do a little something, and all you've got to do is put t into each of these equations.